and we use this detector to detect the particles called muons. So, what are muons?
Muons are elementary particles. They are like electrons. They have negative charge, same charge as an electron. The basic difference between a muon and an electron is that muons are around 200 times heavier than the electron. There are also antiparticles of muons called mu plus with a positive charge. Where are these particles found? A lot of muons and their antiparticles are formed in the atmosphere and they are coming down all around us all the time. We can't see them with our eyes, but using this detector, mini-ICAL, we can see the track of these muons. So let's take a look at mini-ICAL.
Mini-ICAL. It looks big, but it's easy enough to understand. It has two major components, the active sensors and the electromagnet. Active sensors are called resistive plate chambers or RPCs, and these RPCs are placed inside these trays. And we have 10 layers of RPCs which are stacked here in between these blue colored iron plates of mini-ICAL. Now here comes the electromagnet. The electromagnet of mini-ICAL is made of a set of copper coils and these iron plates. And these plates form the core of the electromagnet. Now we will get an idea of how these active sensors are built and how they work.
So here we can see an RPC that is under construction. You can see it's made of two glasses. The two glass plates, they are kept one on top of the other with a small gap in between them. The gap is maintained to be 2 millimeters by keeping these buttons as spacers. In this RPC, you can see the buttons here, 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 and the sides of the RPC, they are sealed, so it forms a chamber. We have these tubes through which we will flow a special mixture of gases through the RPC. Now let's see what happens when a muon goes through the detector. Let's say a muon went through this point. It will knock off some electrons from the gas molecules in the gas gap at that point. But there will be only a few electrons, around 10 electrons, and we cannot directly detect them. So what we'll do is we'll paint the RPC, this side and this side, with a conductive paint. Such an RPC you can see here. This black coat on this RPC is a conductive paint. Now what we do is we'll apply a high voltage across the RPC. Now the muon went through, it will knock off some electrons. Those electrons will get accelerated towards a high voltage positive terminal, and as they get accelerated, they will knock off more electrons, and wherever the muon went through, there will be a current there. So how can we read out this signal? So for this, we use picker panels such as this. So you can see the copper strips on the picker panel, and there will be two picker panels. There will be one picker panel on the top and one on the bottom side of the RPC. The bottom picker panel of this RPC, you can see it here. The strips are facing this direction. So in the top side, we'll keep the strips in a perpendicular direction. So we have seen that when a muon goes through, there will be a current in the gas gap where the muon went through. Now with these picker panels, what happens is, let's say a muon went through here. The nearest strip in the picker panel, the top picker panel, this is a strip. This strip will have an induced signal, and in the bottom picker panel, this strip will have an induced signal. So by looking at which strips have signal, we can know the x and y coordinate of the muon in that layer. These strips are connected to these boards. These are amplifier boards. You can see on top, this is a fully assembled RPC. These are the amplifier boards that are connected to the bottom picker panel, which will give the x coordinate, and these are the amplifier boards that are connected to the top picker panel, which will give the y coordinate information. The amplified signals from these amplifiers, they are fed into this data acquisition board, which will store the data for future. Now with one RPC, we will know the x and y coordinate in that layer, and with 10 RPCs in a stack, we can know the track of the muon. So right now there are many muons going through this detector, and we can see the tracks of them over there in that display.
We have already seen the components of electromagnet. So, through these copper coils, we flow a current of 900 amperes in this direction, which will generate a magnetic field in this direction. Thus, these iron plates will get magnetized to a field of 1 Tesla. 1 Tesla is such a high magnetic field. It is almost 20,000 times bigger than the Earth's magnetic field. But it is mostly contained inside these iron plates, and outside it is much less. Say I am standing here. As you can see, the effect of magnetic field is almost negligible. But when I am moving closer to the iron plates, you can see the effect of magnetic field. Now we'll talk about the purpose of electromagnet in mini-ICAL. Since we know that a charged particle bends its path when it passes through the magnetic field. Suppose mu minus is coming from the top and is passing through the magnetic field, which is in this direction, will bend its path in this direction. And its antiparticle, which has positive charge, will bend its path in that direction. So, by looking at the direction of bending, we will get to know the charge of the particle, whether it's plus or minus. Also, a more energetic particle will bend less as compared to the particle with low energy. So, by looking at how much it bends, we will find out the energy of the passing particle.
So, we have given you an overall picture of how mini-ICAL works. There are a couple of auxiliary systems also. I'll just touch upon them. We have these coils which carry a high current and it may heat up the coils. So, to prevent that, we flow chilled water through the coils. Second, we have an auxiliary system called gas system, which will mix the gases, a special mixture of gases that are flown through the RPCs. We also have a high voltage system here, which is used to apply high voltage to the RPCs. That's it.
So that's all about mini-ICAL. Thank you for listening.